Now let's calculate a parts per million. So parts per million, as I said before, can be done in two different ways. According to your data sheet, parts per million is milligrams of solute over kilograms of solution. I prefer to use parts per million is grams of solute over grams of solution times by a million, which is 1 by 10 to the 6. I find there tends to be less conversion errors. You can choose either method. I will do both. So, a sample of tap water was found to contain 0.0537 grams of sodium chloride. So the first thing we're going to have to do is convert our mass of sodium chloride into milligrams, 0.0537 grams. Move it up through, times it by 1,000, 1, 2, 3 is 53.7 milligrams. Our mass of solution was 250 grams, so we're going to have to convert that to kilograms, which is 0.25 of a kilogram. Parts per million equals milligrams over kilograms. So milligrams would be 53.7 divided by kilograms, 200.25, and this comes out to 215 parts per million to 3 significant figures. So let's do it the alternative method, which is my preferred method. Parts per million is equal to grams of solute over grams of solution times by a million, which is 1 by 10 to the 6. So 0.0537 divided by 250 equals times 1 by 10 to the 6 equals 215 parts per million. Definitely easier. This is the one I reckon you should use wherever possible. Tick, tick, tick.